Hello and welcome to this video on asynchronous programming using JavaScript. In this video, we will be exploring the concepts of callback, promises, and async await, the modern approach. So without further ado, let us begin. Let me quickly fire up my Visual Studio Code, the code editor I'll be using in this video. And to do that, I will just simply run the command code space dot, and this will open up the Visual Studio Code for me. So in the folder, you can see that I have 4 files. The first one being async-await.js, asynchronous.js, callback.js, and promise.js. And each file represents one concept that will be learning in this whole video. First of all, we'll start with asynchronous.js, in which we'll be understanding the concepts of what asynchronous programming is. Then we'll move on to understand how you can run code asynchronously using callback, and then we'll see how callback is a problem and how promise.js can help me solve those problems, and then we'll move on to async await. So let us begin with asynchronous.js. So in coming from a non-asynchronous or basically a synchronous environment, you will have things like multi-threading, and where you can actually run code parallelly using multiple threads, and you don't have to actually wait for your code to run some other code. But JavaScript is single threaded. So what do you do when you need to call codes like database calls or maybe an API call that can take, I don't know, some amount of time that you don't even know. Sometimes it could be 10 seconds, sometimes it could be 5 seconds, other times it could just be in milliseconds. You don't know. Based on the latency or based on the response or the compute from the server side of the API call or the DB call, that time could be vary, and now you need to wait for it to complete a task. Your code is dependent on that. How do you tackle this problem in a single thread environment? Because let us assume that you want to do let's say 10 things in the system. Maybe 5 people are calling your API that you created using Node.js, and one of them just called an DB, and the DB is taking 20 seconds to respond for that API call. And if your code was single threaded and you're stuck on waiting for that API call, then the other users will not be able to use the system for the next 20 seconds. Now, how do you tackle this problem is very simple. It's called asynchronous programming, and what we do is we'll call the function on background, and we'll let the function to do its task, the API call to complete its task and return to us. And whenever the API returns to us, we'll set another function to be called or triggered after when the function is complete, when the API call is completed and done. Now, if you look at this example that I have created over here, set timers itself is an asynchronous call, and it is not present in the JavaScript factory. This function actually comes from the runtime like Node.js, or maybe the browser like Chrome or Windows of that browser. So set timer is not the part of JavaScript, so it is an API call that runs in the background, right? It's more like a browser API. Now what happens is it will wait for 2000 seconds and then run this function. Now let's assume that it does not know asynchronous programming. So what will happen is it should wait for 2000 milliseconds and also run this code after 2000 milliseconds. But if that's gonna happen, then we are stuck on this code for 2 seconds and we have no idea what to do afterwards, while we could have used the computer to run this code already. That's where asynchronous programs comes into the play. So what will happen here is it will set a timeout on the engine and say, after 2 seconds, please run this function that I have passed to you, right? And move on. As it moves on, it will run this code. And after 2 seconds of hitting this line, it will say, okay, the 2-second timer has expired. I'm calling this function now. And that's what's gonna happen. So if I run this file quickly on my terminal, you will see that's exactly what happens. So this line ran first, and then we waited for 2 seconds and this line ran. So basically this is the whole asynchronous programming. This code ran in the background, and the code ahead was called even before the thing completed. Now that you know asynchronous programming, you need to understand what this function is called that is being passed to the set timeout. And to be really direct about it, it's called callback, as you can already see in the Visual Studio Code window. This is the callback function that we will be learning. So let's understand it with a bit more complex example which directly tells us what's going to happen. In this file of callback.js, I have two functions. So this is my main function, and assuming this is the function being directly called, and this is my db call. And for now, for our system, we'll assume that set timeout is a db call which takes exactly 1 second uniformly. Right now, whenever you want to call this db, you need to pass it a callback function to tell it what to do when I have completed my task. And its task is to wait for 1 second for now, but basically let's assume that's a db call. Now here what we want to do is we'll first print that we are starting an async task, and then we'll call this function. While calling this function, we also pass it another function which is called a callback. So any function that you pass to another function is called a callback. The reason being, it's called back by the function when it's done its work. Okay, so the callback function is being called, and what happens here is set timeout. Once it is worked, it will call this function which calls the callback eventually. That's how most of the callback functions and callback scenario works throughout the Node.js JavaScript environment. But it has a bit problem. Let's say you have multiple db calls and you want to run multiple queries, and each one of those queries fall one after the other. That is, they are dependent on each other. We have such example over here in the promise.js file. So if you look at this, you will see that we have three db calls, three async functions which are doing a db call. The first one is waiting for 1 second, the other for 2, and the other is taking 3 seconds, right? If this is dependent on this and this is dependent on this, and we need to call these, the order, the way we call it on the main function would be do something async, and in the callback we'll be calling the other function here, and in the callback again we'll be calling the last one, and that way we'll keep putting the code on the right side of the window, and it will keep adding. Now let's say this is a simple environment, simple scenario where you have three functions, three callback, three nesting, three level of nesting. But what happens if you have 7 functions, 8 callbacks, and something like that? Well, the code will become unimaginably not manageable. Now what happens is, for me to understand this whole 3 callback thing is tricky, because if I just tell you what's gonna happen, it won't be easy call. You'll have to understand the whole code, see through the whole code, what's gonna happen, what's gonna print. And if I run this, I'm pretty sure many of you will see it differently when it comes to the picture. So this one is a promise.js, and when I run it, you can see it prints, and then it waits for 2 seconds, and then it sprints, and then it waits for 3 seconds, and then it sprints. So that's how it is gonna happen. But can we make this more understandable to us? Can we make it more human readable? And yes, promises come into the picture. So basically what promises are something that you say that they will eventually give you an output, negative or positive. Either they resolve or they reject, but they will give you an output after certain period of time. You promise them that you will give them a result. So that's what promise is, and you can simply wrap all your async tasks in, or sometimes, which is not required, some sync task as well. So an async task, when wrapped in a promise, can then be used with the then chain, right? And that's what we're gonna do here to solve this whole callback hell thing. And I forgot to mention, so the situation of where the code becomes unimaginably unmanageable due to the nesting of a lot of callbacks, it is called callback hell, because you're totally not understanding what's happening in your code. Right, so the way promises work, you simply wrap the whole code inside a promise and you return that promise back, and this promise also takes a callback, as you can say, which is also called executor. It has two parameters, resolve and reject. We'll for now just use resolve, and I'm using the fat arrow syntax here, and wherever we're going to call the callback, we'll rather say I have resolved, you do whatever you want to do. And this is the exact thing we'll be following throughout down to the bottom line. I'll just copy this thing quickly and replace it here and replace it here. Let's just quickly make it 2 and make it 3. And obviously I did a bit mistake here. It's not resolved, it's resolve. Basically it's the name of the resolve parameter. You can also rename it to anything else from here, but you need to use the same one as above here and here. Okay, now we also need to change this whole thing. So first of all, we'll remove the callback. We'll say dot then. Now then is something whenever the async task is completed, it will pass the resolution to dot then, and this also takes a callback in it, not a callback but a function with itself. And when the resolve is called, this function will be called, and all you want to do is just do print this, and you want to return calling the next function, which is doing something else, right? And afterwards you can also chain it with another then, so when doing something else is done, another callback function, you can do your other thing, which is printing this whole thing, this statement over there. Let me just quickly write the code over here, and then I'll make you understand this whole thing. And we can just copy paste it quickly. Then yep, let me remove all this code and make it more imaginably understandable. So now, as you can see, I can chain all this call together dot then, and we don't have a nesting over here, and that's why it's all more manageable. We know after whenever this function is completed, we're gonna call this function this then, and whenever this is gonna complete, we're gonna call this then, and that's how the whole thing works. But again, this is not a complete solution to the problem that we are seeing. It's still a bit unmanageable, and there's a long list of dot then dot catch dot then dot catch. Let's say you want to catch if this function returns an error, then that's a long list of dot then dot catch, and in that case you need to make sure that you have something more manageable, right? In that scenario, we have the new concepts of async await. Just gonna check if this code works the way it should, and I'm gonna run the promise.js file. Yes, it does exactly what the previous one did. It's just more manageable code. Now we go back to our async await file. I'll just save this one. In this file, we are pretty much doing what we were doing in the promise.js file. We have all these promises being called, and we have dot then dot catch dot then syntax over there, and all these functions are, it's exactly the same file, just pre-written for you. So to remove the dot then dot catch chaining over here, we can use the async await format, and what it simply means is you'll say that this function is an async function, which is indicating that this function will return a promise, which it is, since we made it to return a promise. And any function that will use an await format should also be a async function itself. Now, so whenever you're gonna do the async await formatting, you need not to worry about these anymore. So all you have to do is call your function with await before it, await keyword before it. So you see, I'm saying do something async await, do something else async. I think I missed it there. It's await, and then await do another async task. And this way, this is so understandable. It's very clear to us that what's gonna happen one after another. And if you run this code, still the same old thing that we wanted to run. I'm running it, and you'll see it does the same thing. Async 1 is done, async 2 is done, and after 3 seconds async 3 is done. Crazy. If I added console log statements over here for these completed, it would have done the same thing. So that's it, guys. That's pretty much it. If you have any questions about asynchronous programming in JavaScript, still let me know in the comment box. I'm more than happy to resolve them. I had to make this video real short. I really don't want to give you a lot of information and overpower you with that, and I've tried to make it concise enough for you, but still the video became as long as it could be. So I'm more than happy to answer your queries in the comment box. Please like this video if you love this one, and also share with your colleagues and your friends if you want to. And as always, thanks for watching.